Hello people, so today we'll be solving LeetCode daily question that is 1334, which is find the city with the smallest number of neighbors at a threshold distance. And in this we'll be given n cities number from 0 to n minus 1, and we'll be given the array edges where edges I is represents from to and weight, which represents that there exists a bidirectional edge and a weighted edge from in between the cities from n to y, and we'll be given the integer, not the distance threshold, and we have to return the city with the smallest number of cities that are reachable through some path and whose distance is at most distance threshold. If there are multiple cities, if there are multiple such cities, we have to return the city with the greatest number. And notice that the distance of a path connecting cities I and j is equal to the sum of the edge is weights along the path. Okay, for example, we are giving this as a particular city, and these 3, 4, 1, and 1 are the weights. So the output comes out to be 3. Why? I'll explain. City 0 is connected to city 1 and city 2 with the threshold of which is within the limit, that is 4. City 1 is connected to 3 of the cities, that is city 0, city 3, and city 2. Uh, Okay, within the threshold, that is 4. So 1 cannot be our potential answer because we already have a city with the smallest number of neighbors within the threshold value, that is 2. The answer is city 0, but the number of neighbors are 2. Then similarly for city 2, we are having as city 0, city 1, and city 3. But for city 3, we are having city 1 and city 2 within the threshold value of 4. Okay, so our answer comes out to be city 3 because as city 0 and city 3 are the both are the potential answers, but if we have to choose the city with the higher value, so that comes out to be 3. Okay, for this what we'll be doing is we'll be performing a Dijkstra for every particular node. So let's have a first a list of integer. Let's It is an array of, let's call it graph, that is equal to a new array list. Oh, okay, no. Sorry, my bad. We cannot use this because we are having weights as well. So let's use a list of integer array, and let's call it graph, that is equal to new array list. Okay. Now what we'll be doing is we'll be initializing with an empty array that for int I equal to 0, I less than n, I plus plus, graph dot add a new empty array list. Then we'll be traversing in the edges that for int edge in edges, graph dot get no let's say edge 0 dot add edge 1. Okay, we don't have to add a list, we'll be adding a new integer array, so that will be edge 1, uh, edge 1 along with the edge 2, that is weight. And let's copy it and paste it. We just need to change it here, edge 0 and edge 1 over here. Okay, now let's have the answer as, okay, so the minimum number of cities as n, because that's the maximum, and my answer is, let's say, initially -1. We haven't to find any potential answer, so we'll be doing a BFS from every particular node for int I equal to 0, I less than n, I plus plus. Okay, let's calculate the neighbors, that is equal to um, get let's call it Dijkstra, because we are performing Dijkstra only in a way. So in this we'll be passing the graph, my current node, my total number of nodes, and the threshold uh, distance. I don't know this distance. Oh, distance threshold, not threshold distance. Okay, and then we'll be checking that if my current neighbors are less than the n, less than or equal to n, because we are as moving forward with the node, so we'll be finding it the greater. Yeah, if the neighbors are less than or equal to minimum number of neighbors, sorry, my bad, it's min. So I'll be updating my min as neighbors, and also my answer as my current ith node basically. and at the end I will just return answer. Now let's quickly write this function, that is private int Dijkstra. In this we are having the list of integer array, and this is the graph. Now I'm having my source, my total number of nodes, and let's say I'm just calling this k instead of a distance threshold. Okay, now for performing a Dijkstra we need a queue of integer array, basically priority queue. Let's call it BFS, that is equal to a new priority queue. In this we'll be sorting it on the basis of their starting node, so that is uh, let's okay, if we are having a0 minus b0, if we are having the two arrays. Okay, now what we'll be doing is we'll doing a bfs dot add. So yeah, we'll be doing a bfs dot add a new integer array of the source along with its distance, which is initially 0. Okay, and we'll be also keeping a hash set of integer, which is the visited hash set, that is equal to a new hash set. Okay, now while not min bfs dot is empty, what I'll be doing is I'll be polling off the current node. So let's do a int current, that is equal to bfs dot poll. Okay, and now what we'll be doing is we'll be doing the okay, I guess I made a minor error, that here it should be 1 and 1, because we need to sort it on the basis of distance and not on the basis of ith value. Okay, so we are doing a current dot poll, and we'll be having the distance, that will be equal to current 1, and my node, that will be equal to current 0. Okay, yeah, it's source comma 0, that's fine. Okay, and then we'll be checking that if not visited dot contains my node, let's say node. Okay, firstly we'll be adding it to the visited, so visited dot add node. Then what we're doing is we'll be doing calculating the new distance, basically that's a new dist, that will be equal to the current distance, uh, current distance plus oh, okay, so I made some mistake. So here I need to add a for loop, that for int neighbor array in graph dot get my node. Okay, now I'll be finding the new distance, so int new dist, that will be equal to uh, my current distance plus my neighbor's first node, neighbor 1. Okay, now what I'll be checking is that if new distance is less than or equal to my k, with that is my threshold, in that case what I'll be doing is I'll be doing a bfs dot add a new integer array with neighbor 0, neighbor 0, and my new distance. Okay, and at the end after this while loop, what I'll be actually returning is the visited dot size minus 1, because I'll not be counting my current node. And now let's give it a run. Okay, it says NEI. Oh, I made a silly mistake, that's a typo. NEIGHBOUR. Okay, and it gets accepted. Now let's submit it, and works perfectly fine. Okay, so this was it for today. Thank you for watching.